Furter
burner. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, managing editor of Hackaday.
And I'm Tom Nardi, contributing editor.
This is episode 139. This week we'll be looking at a Furter burner, a glowing potato peeler, a hacked smartwatch, and the last atlas. Mike's also on holiday this week, so we've got contributing editor Tom Nardi joining us. Starting off the news today, we have a reveal about Hackaday Remoticon tickets, and this year also t-shirts. It's too sad to have a conference without t-shirts, so this year we've whipped some up, even though we have to do what would normally be SuperCon in Remoticon mode.
Yeah, I mean, I'm definitely bummed that we can't all get together. I think probably everybody is, but Remoticon is very cool, and I do appreciate that we get to see a much wider array of people, right, that would be able to attend.
Yeah, I have to say last year I was still in a little bit of a, cyber Grinch, don't want to participate in online things mode, and now after another year of the beatdown, I've just accepted it. I'm totally happy. I'm actually stoked to go to Remoticon this year.
Yeah, we're getting into the rhythm of it now, right?
It's become the normal, and now I'm good with it. So besides t-shirts, we have a little bit of an announcement that on the Friday, we're going to have some new, to quote Mike Stitch, social shenanigans going on, and a little bit of a party. And then Saturday will be talks, and then the prize ceremony, and then more festive gatherings. If you want to join us, please go to the Eventbrite page. You'll find links in the show notes that'll get you there, and sign up. Signing up is free, but if you want the t-shirt, it's going to be 25 bones plus $10 international shipping if you live outside the US. When we get all the orders processed, we will shoot you a link where you can enter your size and details, and the shirts will magically fly out to you.
I know some people were worried about the no sizes being asked for the shirts, but don't worry. We don't just assume everybody is the same size when it gets closer.
We just give you random sizes.
Yeah. Well, it's for display anyway. You're not supposed to wear it.
These shirts are suitable for framing. What else is going on this week?
Well, I will be peeking my head out of the dungeon and going to the Vintage Computer Festival East in Wall, New Jersey.
Woohoo!
I'm very excited about that. They were virtual last year, but they feel like things have cooled off here in the Northeast enough to make a go at it in person. Masks required, of course, and all the appropriate safety protocols are in place. But it's just a really good time. I went to the first time I went a few years ago. I wasn't really sure what to expect, but it's the whole thing. They're such a welcoming group of people, and they're so passionate about vintage computing, and like even if you don't even know what that means, if you're just new to the whole scene, like they will definitely take you under their beige colored wing and show you the ropes and go over it. And it's really, I recommend anybody who has any kind of interest in computing, really, it doesn't have to be the old school, just to drop in and see what's up. You're definitely going to learn something. You're going to have a good time, and it's going to be good just to get out and see people in person again. I know that's what I'm looking forward to maybe the most, is just actually being able to see these things with my own eyes and not have to look through a web stream. Although there will be, I should say, there will be a web stream. There's an article that's out now on the site about the event, and I don't think the live stream details are 100% set in stone as of the time of this recording, so it's not in there. But by the time it rolls around on the VCF website, I'm sure it'll have a link for the stream.
Yeah, well, in similar but opposite conference news, the announcement just came out last weekend that Chaos Communication Congress is canceled this year, and they're going to be doing that remotely / online again. Basically, Chaos is, it's 10 to 15,000 people in a big conference center, and that's just, the restrictions they would have had to put on it were too much, and the Chaos leadership thought that it would just change the spirit of the thing so much that it's not worth having, and we should hold off one more year. Last year, they also did a remote online thing. It was kind of a multiplayer online virtual worlds thing. It was actually really awesome, and they're doing that again this year. This is probably unannounced yet, but we're going to have a Hackaday assembly there this year. I mean, it's going to be a virtual one, but if you want to join us, there is no reason you couldn't, no matter where you live in the world. Chaos Communication Congress takes place just after Christmas and before New Year's, so we've got a little bit of time. I'll put together whatever we need to do to get an assembly up and running and follow up with more news about that later.
This is a journey into sound.
What's that sound?
What's that sound?
This week's sound was, I don't know why it was in my head. It must be something to do with Hackaday. Have a listen to it.
Take off every hit.
I could hear, but I don't know what it is.
Fair enough. This one was in my head because of something I read on Hackaday this week, and I was wondering how many of the rest of you will have gone back and revisited a sound from your past. If you have, let us know. There will be links in the show notes. Fill out the form. Give us the name you want us to say on the air if you win, and we will roll the magic dice for the people who get the right answer. Pick one and send you a t-shirt. All right, and that brings us to the weekend hacks. What have you got, Tom?
I feel like this one we all were kind of behind the scenes talking about, if nothing else, just for the awesome video.
Yeah.
It's called Sail Drone. This is from Richard Jenkins, and actually his company is called Sail Drone. And they have built an autonomous sail-powered boat that is designed for gathering, in this case, weather information. But if you go on the website, they have all kinds of mapping and stuff. And it went head first into a hurricane, recorded some ridiculous footage.
Yeah.
And then the coolest thing was it was able to broadcast it out immediately over a satellite link. So it wasn't like they had to go pick this thing up, in the ocean and then bring it back on a USB drive or something. It was actually able to beam this all out in pretty phenomenal quality within just a few hours. So, I mean, it's really having that near real-time access to this kind of information is a pretty big deal, especially with an autonomous platform where nobody, you're not risking life and limb to map a hurricane or anything.
Talk about getting seasick. I think this whole thing is very interesting, and it's kind of funny that we, send robots out to Mars and, don't have drones to explore 2/3 of the Earth's surface, right? I mean, our whole damn planet is made out of water. Why do we not have more autonomous vehicles going out and doing science and learning more about it? And weather is the obvious thing, but then some of the sail drone boats they have, I guess they're boats, are significantly bigger. I think this is the small one, which is a 7-meter ship, but then they have a 10-meter and a 22-meter boat, and that's a big boat. And they've got solar and a diesel motor, and it can carry things and go out for half a year at a time. And like you said, it's got a permanent satellite uplink.
Yeah, and I think you maybe miss something if you don't get to see the picture of it either, because it looks a lot like a little airplane riding a surfboard.
Oh yeah, we didn't talk about the coolest part.
And the reason for that is because instead of the traditional sail, it has what is effectively an airplane wing coming out of the middle of the hull, which I guess if you want to get technical, that is what a sail is. Right?
Yeah.
It's kind of like a lifting surface, so they just, forgoed all the rigging and fabric that you might expect, and it's just a solid airfoil. And obviously it works really well.
Yeah, that's really fun. It's got a little tail on it, so it auto-orients into the wind. I think it's also got a motor to steer it if they need to, but it makes the boat kind of run on super low power. I'm totally geeked out about this thing, actually. I think it's I've done some high altitude balloon projects, and then this is the even cooler version of it in a way. This thing gets to go out for long periods of time, do some real science, and the tech involved is pretty neat too. My next hack is demonstrating thermoacoustics with the Rika tube. This is a physics demo video by Bruce Yaney, and you should absolutely check it out if you've never seen one of these things. He has what looks like, 2-inch, 3-4 centimeter diameter tube, and he lifts it up and it starts humming automatically. And you're like, what? This is one of the cooler things I've seen. I don't know how I've never seen one of these before. Inside this tube, about 1/4 to 1/5 of the way up, is a metal screen. And what you do is you heat this metal screen up, and then when you tip the tube vertically with the screen at the bottom, it starts singing. And the physics here is really crazy. When cool air hits the screen, it expands, right? And so then this sends shock waves essentially out toward both ends of the pipe. Because the air inside has also heated up, it starts to float upwards. And so the reflected wave that hits off the top of the pipe pushes this heated air back down a little bit into the essentially heater mesh. But the reflected wave off the bottom end of the pipe pushes fresh, cool air up there and makes it expand again. And so what this gives you is a resonator as the shock waves propagate up and down along the pipe. Every time they bounce off the bottom and go up, they draw a little more fresh air into the heater. It heats, expands, and that sends another shock wave out. It's just such a cool physics demo. And, he takes a whole bunch of these things. It doesn't matter what they're made of. They just have to be tubes. It's like a heat-driven pipe organ or something.
Yeah, it's probably the elevator pitch, right? Is the heat-driven pipe organ. And it sounds a lot like that. Especially some of the larger tubes. I tell you, watching the video, I was almost scared by it. It's so freaky. Like I couldn't really wrap my mind around it. What really helped me understand. A few minutes into the video, he puts like some wood chips in the tube.
Yeah,
and then lights it on fire, and then you can see the smoke and the flame moving. So it's like, okay, that kind of like illustrates what's happening in there. But yeah, and I like all the little tricks he did where like, it only works with cold air going in. So
right.
when he preheat the air, it would immediately stop, because you have to, it's a very delicate balance that you have to maintain for it to do it. And not for long either. I got the impression like when he was doing it, you only get like maybe a few seconds to play around with it. And then and then it stops.
Yeah, well, the mesh cools down and it's not heating the air anymore. And then you don't have no driver. It's really cool. He does all the things to shut it down. Like he puts his hand over the top or the bottom and that stops the convection. So the hot like pocket of air can't move away from the mesh. That kills the vibration. You hold it on the side, that has no convection, that kills the vibration. You fill it with hot air coming up the bottom by using a torch, that kills it. Like, it's really cool, all the things. The one he didn't do is to flip it over upside down. And my guess is that also kills the vibration, because then the quicker of the two bounces will be the one that's pushing the hot air back down. So I think that'll probably damp it out. But like, there's more physics to do here, people.
I like to, in the write-up that Dave did, he mentions, maybe doing, inductive heating or something to keep the mesh hot inside.
Yeah.
To see if you can extend the usefulness of it. And then from going off of that, then you're like, well, can I, somehow turn this into an instrument? And I think someone even in the comments was like, oh, I'd like to hook this up to a MIDI controller and try to play some music on it.
Yeah, I mean, you don't get really sharp transitions, right? Like the note kind of fades in as the thing heats its pocket of air up, and it fades out as it cools down. But you totally could. And actually, just recently, maybe even since you've looked at the page, somebody has put a link in there to a YouTube post where someone made an organ out of it. And it's like the slowest organ you could possibly imagine. But it's pretty darn cool. And they're doing it by heating them up with electricity. I think it's resistive heating.
Oh, wow.
Anyway, this absolutely makes me want to do one of these. And I'm trying to think about how to make it spooky enough that it could be a Halloween prop.
It's pretty spooky. I mean, maybe I'm a coward, but
a really big low one, super low pitched one might actually be really cool.
Yeah, he did. I think the carpet pole.
Yeah,
like the cardboard ones. And when he turned that, I was like, "Ooh, I don't like that noise."
I'm gonna have to find one of those. I think
that triggered some kind of evolutionary response in me. I was like, nope. Time to go back in the cave.
Yeah.
All right, something I really liked reading about this week is called Forget Digital Computing, You Need an Analog Computer. We all are familiar with digital computers, right? We're listening to this on one of them right now in some shape or form. Relatively few of us have ever experienced an analog computer, and there's a lot of great reasons for that. Probably chief among them is it's very difficult to find tasks that an analog computer excels at. It usually is something like a simulation or that kind of thing, and they are much more difficult to use than a digital computer. But that doesn't keep people from being interested in them. And a company from Berlin called Anabrid has put out an open source analog computer that's called that for that analog thing. If I had to describe it, it looks a lot like an old like telephone switchboard kind of, because you have the plug board where you're gonna physically program it, for lack of a better word, by hooking up diodes and capacitors and that sort of thing, and then you have a bank of dials and just one simple little output, which I imagine is actually showing voltage, because that's usually how these kind of things work. And it's a really impressive project, not just the hardware, but if you look on their wiki, they kind of give you what kind of applications you can use it for. They give you some demo applications, talk about the theory behind it. I think it's a really cool chance to look at something that most of us would never have an opportunity to play with, and I think there's probably also something to be said there about, there's a lot of talk about how, the Arduino has kind of taken away people's knowledge of the basics, right? The old school doing everything with discrete components, and an analog computer is nothing but discrete components. So I think there's a learning experience to be had there. If you really want to dive into building circuits and seeing what they do, this would be a great way to do it.
And what this thing looks like to me is an analog synthesizer. It looks a lot like a modular synthesizer unit. In fact, I think there's definitely been some cross-inspiration there over time. Like, I know that Bob Moog and some of the early analog synthesizer people had analog lab gear around and were making music by, tweaking their otherwise reasonable voltage generators. I think this may have gone a little bit the other way. Like, this is an analog computer that's a little bit styled like a synthesizer. It's really neat. One of the trickier points of analog computing that you don't think about is kind of they have to have these ultra precise sample and hold circuits that take an incoming voltage and retain it until it's kind of processed on, until the next step in the computation. And doing those so that the capacitors and the transistors that make up these sample and holds don't leak limits the accuracy that you can have in an analog computer and stuff like that. And the slew rates of the op amps they use are what limits the speed at which, kind of the data can propagate through the system and things like that. It's a really, I don't know if you've played around with analog synthesizers, it's kind of a bizarre way to think about computing. This is a really cool demo, both from like the analog computing side where you can like make a chaos attractor or do damped oscillators and, maybe get a different intuition for how those systems work by plugging them through voltages. But then you can also like play around with it. I bet you could plug it into speakers and make a hell of a racket.
Now you mention it, I can't stop seeing this thing. Like if it was in a DJ booth or something, I wouldn't even give it a second thought. Now,
yeah, right?
Like even like the font and like the way the knobs are, it really does look like some audio equipment.
This next one is one of my favorite kind of hacks. It's a glowing potato peeler makes a Nernst lamp. My favorite part of this isn't the potato peeler. It's not even the Nernst lamp. The fact is that Drop Table Adventures read an article on Hackaday, an old retro tech-tacular about Nernst lamps, and then saw another video of a YouTuber, Photonic Induction, and thought to himself, hey, I need to make one of these.
Gotta get in on this.
And I just love the, Hackaday feedback loop going on here. So Absolutely. Good on you, Drop Table. A Nernst lamp is a weird old lamp that predates the kind of glowing filament in a vacuum lamps that we think of. instead of a filament which would burn out if it weren't in a vacuum, it uses a chunk of ceramic. And the advantage of ceramic is it's already oxidized. You can't like burn it out. So it can glow in the open air if you can get it hot. The disadvantage is that ceramic isn't a conductor, of course, and so you have to pick your ceramic carefully. Here he's using zirconium oxide, which is kind of a semiconductor, but not at room temperature. So step number 1 is to make this thing hot enough that it starts to glow a little bit. And Drop Table does that actually with a torch, lighting it up. And then he just starts cranking up the amps. And the thing glows. And it makes a fantastic, like, dangerous, hot, and inefficient desk lamp.
Yeah, there was really something almost like post-apocalyptic, seeing him like kickstart a light with a flame.
Right?
You know, it really looks like something thrown together in a dark alley somewhere. But it worked. It made it an impressive amount of light, I thought, for a potato peeler. It certainly outperformed my expectations for a kitchen implement. I'll put it that way.
So potato peeler is because it was one of these ceramic blade potato peelers, by the way, we should say. And so he happened to know that these had this kind of zirconium oxide. And you don't have to heat them up with a torch. The old school ones actually had a secondary heater coil that would go around them. And if you watch the video we have linked in here, our Retro Tectacular on it, they go through and explain how there was actually a clever relay circuit that would run the heater coil until it heated up the glower coil enough that it started drawing current. This current passed through the coil of a relay, which then shut the heater off. So it's like this, I don't know, it's this lovely like late 1800s electronic technology that might have been pretty amazing back then, now that I think about it.
Well, yeah, I kind of got that impression from the Retro Tectacular write-up, too. It's like, now we look at it as some cute little things people are doing on YouTube, but at the time, like, this was high-tech stuff, and it seemed like, this was maybe the way things were going to go until the light bulb we all know and love took over.
Electricity in the home was new,
yeah, absolutely.
And gas flames were dangerous, and these things were pretty robust. But you should definitely watch Drop Table's video because he goes through all of the problems in making this thing work. And if you use too short a piece, it gets too hot. And if you use a long enough piece, it's got to be kind of the right length to get the right resistance, to get the right heat in it. And it melts copper wire that you try to attach to it. And I think the old ones had like palladium or platinum leads or something, that these days would be absurdly expensive and probably not worth it. But, back in the day when this was the electric lamp you could spend for this.
And I think at the end of the day, it was really just to avoid having to pull a vacuum, really. Too,
Yep.
we just, something that now we kind of take for granted. Oh, yeah, whatever, evacuated little chamber with a filament. It's no big deal. But back then, they're like, oh, man, that ain't gonna happen. So
it's really hard work.
Yeah, let's figure out some other thing. And it only seems convoluted because we have modern eyes to look at it. Back then they're like, yeah, this is a great idea. Next up, I've got Hackable Smartwatch is also open source. I will admit to maybe being a little confused at first when I read this one, because it is not the watch itself that's open source. In fact, the watch, from when you look into it, is actually a commercially available smartwatch. But what is open source is all the software that runs on it and the app store that's being developed. It's the kind of thing where they found a cheap smartwatch on AliExpress and they figured out how to reverse engineer it, and they don't know everything about it, but they know enough to make a firmware and start pushing apps. And that's all you need to start a community, right? Like, the write-up kind of starts off with saying that, many people were unsure about smartwatches and what their use could be. And I'll admit to being one of those people. I kind of don't get it still.
Sure.
I'd love to be proven wrong. And I think, a smartwatch that had an easy to use SDK and a whole community of interesting programs might be what pushes me over the edge. Like I need to see something unique, and I hope that the open source community can come up with it. Some kind of justification for wearing this little doofy thing on my wrist.
Come on now. I mean, I haven't worn a watch and I don't even know how long, but it's not the worst thing. And what, this one speaks Bluetooth?
Yes, it's a Bluetooth system on a chip. Decent hardware for the price anyway. It's something, under $30 on the usual. If you can get one, that is one of the problems. They said getting them is actually hard. With everything else right now, like they're cheap, but actually getting it delivered in a reasonable time is tricky. So yeah, you can hook up to all your Bluetooth stuff. There's no Wi-Fi, it looks like, but you could always have some kind of little gateway thing to hook up to your home automation. I was paging through the little app store kind of thing they have. It's all web-based. And there were some little you use it as a BLE joystick kind of thing. So that was kind of cool.
Right.
Like you could connect to a robot and move it around. I was like, all right.
Oh, using the accelerometer in it or what?
Just with the touchscreen, it looks like.
Oh, it's got a touch screen. My bad.
You also add your own buttons, it says. I was looking at the app. It's pretty cool. Yeah, I mean, so it's interesting just to look through the different apps available. There's a BLE scanner for it. That's pretty cool. I'll give them that one. Going through it, I kind of get it. There's another Bluetooth joystick. It says emulates 5-button joystick. This one says with accelerometer and touch. Bluetooth keyboard. That's kind of weird, but all right. I'm intrigued. Camera shutter. All right. Yeah. I mean, so that's it. It's a surprising amount of apps already ready to go if you pick one of these things up.
Yeah, there might be a whole bunch of dumb uses for a small computer on your wrist that just does, a little bit of radio, a little bit of connectivity. I could totally see it. I'm kind of all in favor of these random hackings and improvings of commercial crap anyway.
Oh, yeah.
I always find the kind of imagination of the people making these devices to be a little bit limited. I mean, and they're trying to sell 1 million of them. So they're trying to make it kind of lowest common denominator. And then the hacker community gets to it and it's like, oh, let's make this thing a XYZ, right? We'll tie it in with my particular bizarro niche home automation system. I love that sort of stuff.
Yeah, we've covered so much of that where they'll pick up one of these things and come up with a custom firmware for it, and suddenly this little cheapo device is the must-have hacker gadget. I did, article a while back about the, custom firmware for little Bluetooth thermometers, and now those things are I see them everywhere now. Everybody's selling them because you can, flash the new firmware onto them and do all kinds of stuff that they were never designed for, and they're the perfect little. I think I got 10 of them. I can, if I turn around now, I have them stacked up because they're so cheap. It doesn't make sense to buy one if you got to wait so long to get them anyway. So you buy a bunch of them and put the firmware on them, and I know they can thank the open source community for selling plenty of them things.
And speaking of consumer crap, investigating a defective USB power bank module. This is a teardown and repair by Majenko of, a defective USB power bank module. What I like about this one is the way Majenko goes about analyzing the problem. It's a power module. It's not super complicated, but it's got a black solder mask on it. And I suppose you could try to trace out the circuit that's embedded in here. But man, what a pain. So instead, Majenko just desolders everything, sands off the solder mask, and has a look at the raw copper. And it's glaringly apparent that turns out one of the traces just didn't go to the pin it was aimed at. They made some horrible mistake in the board design phase, and they're like, well, we'll go through with it anyway. What the heck? Once Majenko's got the circuit and knows what the main chip driving the power bank is, you can compare it with a reference design, and Majenko discovers that there are also 2 resistors missing. So not only is one trace bad, just doesn't go where it's supposed to be routed, but there's 2 resistors missing. Fixes it, and it works as intended. But what I love here is just the kind of, if you have a few of these things, the brute force, desolder the whole darn thing, sand it off and look at the traces. It just saves you so much time that if the device you're looking at is only going to cost $10, it's going to save you a couple hours of headache trying to stare through black solder mask.
I know he had a bunch of them too, so it was like, well, this will
Yeah.
just be like the sacrificial lamb to like, I'll tear one up, and it does. It looks, it's amazing. It gives you such an insight into how it works, and especially the way the trace just stops. It's almost
embarrassing.
funny,
Yeah.
but it's blatantly obvious when it's all sanded off. You're like, oh wow, okay, I guess you had to drag that a little bit farther down before it would connect.
Dead end.
And it's amazing that there was literally no chance this thing could ever work. Like, it's impossible, and they shipped them out anyway. So like, forget about like any sort of quality assurance.
Control.
Like, they did not even remotely test this thing, because it's not like, oh, it might work. Who knows? No, look, it will not work. It's not connected. It's missing parts. It's just good for taking a picture and putting it on your website.
Yeah, well, probably that's why Majenko got it so cheap, right?
Yeah. Yeah, I think even at the end of the write-up, he theorizes like these must have been like a prototype run or something. Like, they were clearly not meant to be sold, and somehow they're on the market. And I think he said he was able to get his money back or something. They guaranteed it was in the end. He didn't have to. Yeah, it wasn't like he has to live with these things. Like, they did right by it, but.
Well, he can fix them too, so that's a super win. Now you got the things for free for the price of repairing them.
Yeah, right. I know I've like picked up little modules, as you do. They're so cheap, and you add something to your cart. I've finally messed with them later, and I'm like, oh, that doesn't even work. So it's like, I don't even remember where I got it from or how long ago. And now it's like, well, I guess I'm just stuck with this. So at least he's got the, the chain that goes back to like the original source still.
Yeah, and this reminded me of an old talk by Joe Grand on basically doing the same thing with PCBs of all sorts. I'll throw the link into the show notes. This is his talk from DEF CON on deconstructing PCBs, where he goes through like all the ways to do this. And Majenko does it kind of the easy way, the caveman way, the simple way with sandpaper. And honestly, if you're just going to do one side or two sides of a board, that's probably the right way to do it. And that's actually Joe's conclusion from this talk. But then he goes through all the other ways to take apart a PCB. Uses an example, I think it's an 8-layer old iPhone PCB or something. There's a lot hidden in those middle layers. And if you actually want to reverse engineer something, and it's a 4-layer board, and it's not just power planes on the inside, or it's a 6-layer board and there's real circuit routing going on, like, they're hiding things from you. You need to take those parts off and take that board apart. So he goes through some chemicals that actually board houses use to remove solder mask when they make mistakes. You can laser the solder mask off, and what you can't do is mill the solder mask off very well because it's not a level surface, and so you can't really follow it. But once you get that solder mask off and you're looking at the top layer of copper, you might be interested in digging deeper, and that's where a CNC mill comes in super handy. If you're feeling absolutely deluxe, Joe goes and finds a metalworking shop where they have a surface grinder, and he goes through and just absolutely precisely down to like the thousandth of an inch or something, gets these things surface ground to each different layer, and you get these just absolutely beautiful results. But this sort of take the parts off, sacrifice one of them, map out the circuit board as easy as you can is a great tool to have in your toolbox.
I almost wish the next little module I ordered doesn't work so I can sand it down and have an excuse to take pictures of it.
Yeah, right? Oh, dude, if you get a good teardown.
Yeah, right? My first quick hack for the week is Raspberry Pi plots worldwide earthquakes by Craig Lindy. The end result is a little desktop display that shows earthquakes all over the earth, and it's, cool little thing. But what I really liked was the journey getting there and reading how he started with an ESP32, and he started in fourth, and then it went to C++ and Python. And I think it's just an excellent example of, just because the end result doesn't look like what you started out working on doesn't mean it's a failed project. Next up is What's on Your Bank Card. Hacker Tool teaches all about NFC and RFID. This is kind of a quick update from the team behind the Flipper Zero, which we've covered before. And nothing hugely surprising here. It's Flipper Zero does Flipper Zero things. Like, this is what it's meant to do. But It's just a cool example of how the device can be used to pull information off of contactless payment systems, as if we needed any more reason to be looking forward to when this thing actually ships out. And lastly, I have Furter Burner cooks the wieners just so. This comes our way from Wesley Treat, and it's a little grill for 2 sausages or hot dogs, depending on what you want to call them. What I really liked about this one is just the behind-the-scenes view you get, how he went from CAD to, doing it in wood, figuring out what worked, what didn't work, and then ultimately cutting it out of metal so it could be all welded together.
My first quick hack this week comes from Daniel. It's a great tip, removing thread-locked screws with a soldering iron. This is today I learned that thread locker, like Loctite and stuff, degrades with heat. So if you're having trouble getting a stuck screw out and it's held together with thread lock, heat it up, melt the thread locker, and then give it a twist. It might be easier. Next up is a project from Copper Dragon. Breadbin is an 8-bit TTL CPU on a breadboard in a bread bin. This is taking a breadboard computer and putting it in a bread box. That's not what's really cool here. What's really cool is the nice design. It's an 8-bit computer made out of 74HC logic, mostly with a couple of those fast 74AC chips thrown in crucial speed zones. This is not Copper Dragon's first breadboard computer, definitely his best. And bringing up the rear, Atari ST still manages campground reservations after 36 years. This is a YouTube video by Victor Bart, where he interviews France, a campground manager who uses, after all this time, some custom software that he wrote for an Atari ST to manage enrollments and check-ins and checkouts at his campground. I can see why he would keep it running. It does everything he needs to do, and it's got this great splash screen that's got a picture of him as he was 36 years ago with a beard and fuzzy hair. It's amazing that this computer's still running and still doing its work, but if the job's simple enough, why change it? And that brings us to our can't miss hacks. These are long-form original content written by our fantastic Hackaday writers. Tom, you're up first. What do you got?
I really enjoyed 3D printing, corrugated plastic for cheaper and easier enclosures by Donald Papp. Donald's been doing a 3D printing series for a while now, looking at kind of the nuts and bolts of 3D printing, things you don't always think about before you hit buy on that cheap 3D printer. Today's topic is building an enclosure, which you will probably want come the wintertime, and you start figuring out that your prints aren't sticking to the bed because it's too cold. And the traditional logic is to use, acrylic panels and put them together with 3D printed parts or wood or something like that. Problem is that acrylic is not as cheap as we'd like, and it's also not super easy to work with unless you have access to, a laser or CNC router or something. I mean,
I wouldn't touch it with a CNC. With a laser, I'll give you the laser, but that stuff,
yeah.
It like melts and it gums up your CNC as well. It's like really touchy. I hate acrylic.
Yeah, and even trying to, cut it on like a table saw or something, you really gotta have the right blade. It's very easy to melt. It's not easy to work with. That's the short version. It's not easy to work with, especially if you don't have the right equipment.
Unless you have a laser cutter, and then acrylic is the shit.
Yeah.
Beep.
So Donald says, well, why don't we look at using corrugated plastic in place of acrylic for a lot of these things? It's much cheaper. Very easy to work with. You don't need anything more exotic than a sharp blade and a straight edge. It's not clear, unfortunately, but you can cut a hole in it pretty easily. And he makes a pretty compelling case for why you could, retrofit these 3D printer enclosures with the corrugated plastic. The big stumbling block that keeps this from being a one-to-one replacement is that the corrugated plastic is actually a little bit thicker at usually around 4 millimeters compared to acrylic, which is often sold in 3 millimeter. So, as sort of a proof of concept, Donald took the very popular LAC enclosure for the Prusa printer and redesigned the printed parts to take the new material. and it looks great. I mean, it looks great.
solved.
You can't see through it, like you said, but it's something that you could just do it with hand tools. You don't have to outsource the big acrylic panels. And it also kind of made me wonder, is this just an underutilized material in general? It's not an ideal material, obviously, right? It's pretty flexible, but you can work with it easily. You can go any kind of sign shop and pick it up. For the home gamer that doesn't have access to CNC, lasers, all that kind of stuff, is this something that we could be looking at more for enclosures and that sort of thing for different projects?
I don't think it is an underappreciated material. I have a bunch of sheets of it in the basement right now. I'm looking around the room, and I made some cabinet drawer things for stashing stuff in the closet with it. I think it's the awesomest material. And if you have an election every 4 years, there comes a time when it's, or realtors, there comes a time when it is absolutely free all around. And actually, we just had an election here in Germany, so it's time for me to go harvesting.
That is an excellent point.
The signs are ripe. There was a circus in town last year that didn't pick up any of their signs, which is, of course, illegal. So I do the neighborhood a favor, and I just go and harvest them all, and they're a good meter by 2 meters, and you can make anything out of them. It's a lovely material.
Do you repaint it, or does all your stuff just have local politicians' names on it?
I try to use the backside, which is usually white.
Not exactly ideal. I wonder if there's some way to bleach them or something to take the ink off them.
Yeah, I wonder. That brings up some of the problems is working with this stuff. I guess it's polyethylene or something, and it doesn't stick very well to anything as far as I could tell. And so there must be specific polyethylene glues that'll work with it. I've used kind of rubber cement, and that works pretty darn well, but it's not a super strong bond. The people who do it professionally heat weld it together, and that... I've actually seen a boat built this way. I was looking for the links for this, stumbled on another boat build that I'll throw in the show notes. But I was looking for a boat build where the guy was butting the sheets together with a hot air gun, and he would run up and down the two sides, get them just to the melting point, and then sandwich them together, and got some really good bonds out of that. I think do that outdoors, because the fumes when you heat it too far is probably not something you want to get into. But other than that, it's a really awesome material. The boxes I made, I actually riveted the corners of them just with, pop rivets from the hardware store, and that works really well.
Well, I think I'm going to start going out and collecting political signs.
Do it!
And try my hand at it, because this has gotten me inspired to... I'm trying to use the backside, though.
Yeah, right?
I'm trying to use the backside, if I can help it.
We'll figure out how to paint them.
Yeah, right.
My next article this week is written by Hackaday contributing editor extraordinaire Tom Nardi. This is counting down to the final Atlas rocket. And I like this story because, again, I'm on the edge of the space thing. I'm not as clued in as you are, Tom. And so I just love to see what you think about the whole thing. The basic story here, before I get to grilling you for the nitty gritty, the basic story for the audience is that the United States has been launching rockets on the Atlas platform for 60 years now. And a bunch of different series of rockets. And they've gone from being basically missiles to the kind of Atlas V, the latest generation, which has a fairly heavy carrying capacity. I thought it was really great that you went through a retrospective of all the cool things the Atlases have carried up into space. But then get to the point here, which is that the engines for the Atlas have been made by Russia for how long?
They've been using them since 2000, but they're actually Soviet engines that were made for their Buran shuttle in the 80s. Right. So they actually go way back, and it's kind of a testament to how advanced these engines are, that even though they're as old as they are, they're still phenomenal. And they'd love to use them if it wasn't for the political ramifications of...
So we're using secondhand engines from the Russians in the 80s to fly our rockets to space. That's one of those things that would drive nationalist people insane. But with reason when things get sour between the two nations, right?
And that's kind of where we are. I mean, they in 2016, Congress said, we don't really like the idea of launching national security payloads with Russian engines. There's certainly a case to be made that kind of thing should be done domestically. So if it blows up, we don't have anybody to blame but ourselves.
Yeah, right.
So, and that was kind of one of the big reasons that they're going to sunset the Atlas, is that if you can't fly, those lucrative national security launches, then it's suddenly a lot less of a reason to maintain this very expensive platform. So the hope from United Launch Alliance that operates the Atlas is that they are going to have a whole new rocket that, if you look at their press release, they say basically it's built for the ground up for these national security. Like, they're happy with that being their bread and butter. And I mean, it's a serious piece of butter. I mean,
right.
the government pays very well to put these classified things in orbit. So even if that was their only customer, they'd be fine with it. So they're kind of like looking at what the government wants, just going one by one down the checklist. Like, all right, it can do this, can do this, can do this. We don't use any Russian hardware. And the only problem is it takes a long time to build a rocket, and especially when there's different vendors at play. And they're supposed to be flying in 2022, but they don't have any workable engines because Blue Origin is still fiddling around with the design. So they may have painted themselves into a corner.
A question that a lot of people in the comments have asked, and I'm interested in too. So they're going to make kind of a whole new ground-up design, this Vulcan rocket, along with the new engines. People in the comments were saying, how much is an Atlas V like an Atlas 1 or an Atlas 2, and how much has changed in the last 60 years. And that makes me also think, then how different is it for them to do a, quote, clean slate design like this versus, change from Atlas 4, whatever the differences were between the 4 and 5 design or whatever. You'll know this sort of answer.
Well, at one point they had talked about just switching the engines on the Atlas 5. Like, that would be an easy answer, right? Because the engines are a problem, we won't use the engines. But you'd need to get someone to, build an engine that's basically identical, but in the U.S. And that's kind of tricky. There was talk about licensing the design, but then at the end of the day, you're still using a Russian design. So then they said, well, if we're going to do a new engine, the RD-180, the Russian engine uses kerosene and liquid oxygen. The push now by a lot of the new space companies is to use methane. Easier to source and better for the environment. So now if you're talking about different propellants, then the game's totally changed, because the temperatures that they need to be held at are different. The density, the tanks can't be the same size. So if everything changes at that point. Once you got to change the tanks, a rocket is little more than tanks with some skin wrapped around it,
Right,
so once the propellant was changed, then it's at that point it's like, well, we might as well start over.
So it really is a clean slate design.
It does still have this, the solid rocket boosters that attach to the sides. They're actually an upgraded version of the ones that are flying on the Atlas V. So that's carrying over to Vulcan. Vulcan will use the same upper stage. What we're talking about pretty much just the first stage, even when we're talking about the Atlas, because the upper stage is a Centaur. It's a whole different vehicle that rides on top of it. So it'll use the same upper stage, it'll use the same boosters, but that core stage, what really accelerates everything up, is going to be all new and much wider too, which is also going to be a big change. You got to change out a lot of the ground support stuff because it's a bigger diameter rocket.
Well, that sounds like a lot of work.
Yeah, it's a lot of work.
Is there any thought that they should just scrap it, let SpaceX do it?
I'm sure SpaceX would love that, but right? It's good. I'd even say probably necessary to have competition, especially for, the government launches. SpaceX has had an excellent run, and, we wish them nothing but the best, but who knows what could happen. A Falcon could blow up tomorrow, and then the whole fleet's grounded for a year until they figure out why.
Right.
So, you need to do, even if they can't make the Vulcan cheaper than the Falcon, and I think that they probably won't. I think they're trying to get close, but I don't think they'll ever get cheaper than the Falcon. even if it's a more expensive rocket, it's worth it, especially to the government, to have it in that back pocket so that worst comes to worst, they'll have another way to space.
And that brings us to the end of this week's Hackaday podcast. Be sure to check out the show notes, Hackaday/podcast. If you want to reach out to us directly, shoot us an email, editor@hackaday.com. If you see anything cool or you do anything cool, let us know. We'd love to hear you. tips@hackaday.com. And until next week,
keep on hacking. Give me a second. Something very strange has happened. I can hear myself. Killed it with fire.
Then my next hack is .com.
All right, how do I want to do this? No, I think it's cool. No. Furter burner.
On your mark, get set. Here I go. All right, here we go, for real.